All right, ready to dive in. We're going to be talking about data structures today.
Cool.
We're looking at this blog post, deep dive into data structures, essential knowledge for coders.
Okay.
Sounds promising, right?
Yeah.
Whether you're, knee deep in code every day or just curious about how things work, this is going to be a good one.
Yeah. It's funny. People always compare data structures to building blocks and programming.
Yeah.
But I almost see that more like a spice rack,
Ooh, okay, I like where you're going with this.
Like you could technically bake with flour and sugar and eggs.
Right.
But it's the cinnamon, the nutmeg,
Yeah.
the cardamom, that little extra oomph.
It's what makes it special.
That's what data structures are. They're the spices.
Okay.
They make it interesting.
I'm already more intrigued than when we started this, I gotta say. So if we're thinking about a spice rack, what's like the salt of the data structure world?
The salt. I'd say that's our good friend, the array.
Okay.
So imagine you have this perfectly organized drawer, and everything's in its own little compartment, all in a row.
Okay.
That's what an array is. It lets you store data in order so you can access it super fast.
So is that like when I finally cleaned out my sock drawer and I know where everything is?
Exactly. Finally, some organization, right?
Right.
Yeah, and just like you want your socks to be organized.
Yeah.
Programmers use arrays when they need that data in a specific, predictable order.
Okay.
Think about it. When you open an image on your computer, each pixel, all those colors, that information needs to be stored and accessed incredibly quickly.
Right.
That's where arrays come in.
Makes sense. Super organized.
Super organized.
But then the article mentions linked lists.
Yes.
Which seem a little bit less, shall we say, high-strung.
A little more free-spirited.
A little more free-spirited. Exactly.
Yeah.
What's the advantage of that over our nice organized array?
Well, sometimes you need things to be a bit more flexible.
Okay.
Imagine like a chain.
Okay.
You can add or remove links without messing up the whole thing.
Right.
That's what a linked list is like.
Okay.
And a great example of this is your web browsing history.
Okay.
You need to go back, you need to go forward, new pages are always being added,
Right.
it needs to be seamless.
So you're telling me my browser history is basically just a big linked list party going on?
Pretty much, yeah. Each web page is like a link in the chain, and your browser can jump between them super efficiently because of that structure.
That's pretty cool.
Yeah.
I never thought of it that way. That's really neat.
Yeah, it's a good way to think about it.
Okay, so we've got our very organized arrays.
Yes.
We've got our more go-with-the-flow linked lists.
Right.
What other data structure delights await us in this article?
Well, let's talk about stacks and queues.
Okay.
These are interesting because they both deal with data in a specific order,
Right.
but they have different rules.
Okay.
Imagine a stack of pancakes.
Okay, I like where this is going.
You can only add pancakes to the top,
Right.
and you can only take pancakes from the top.
Right, it's the only way it works.
Exactly. That's how a stack works. Last in, first out.
Okay.
It's called
LIFO. All right, got it.
and we use this in programming too.
Okay, so how do those pancake stacks, how does that translate into the code that makes my computer work?
Think of the undo button in a text editor.
Okay.
Every time you type something, it's like adding a pancake to the stack.
Okay.
When you hit undo, you're taking that top pancake off.
Gotcha.
You're reversing your last action.
So stacks are kind of like the time travelers of the data structure world.
In a way, yeah. They let you go back in time, step by step.
That's really cool.
Yeah.
Okay, so if stacks are LIFO, I'm guessing queues are
Queues are FIFO. First in, first out.
first in, first out. Okay, so the opposite.
The opposite. Think of it like a line at a coffee shop.
Okay.
First person in line gets their coffee first.
Makes sense, so it's very straightforward.
Straightforward but powerful.
Oh.
They're used all over in programming.
Really? So even though it's such a simple concept, where would you even use that?
Tons of places. Think about managing print jobs on your computer
Okay.
or handling notifications on your phone.
Right.
Queues make sure things happen in a fair, orderly sequence.
Wow. Okay. I'm starting to realize I know nothing about how my devices work.
Huh? It's a hidden world in there.
It really is.
It is.
So we've covered arrays, we've covered linked lists,
Right.
we've talked about these pancake stacks and these very orderly queues. The article also mentions hash tables.
Ah, yes.
And I've definitely heard that one thrown around a lot.
It's a good one.
It always sounded kind of intimidating to me, though.
It's not as scary as it sounds.
Okay, good.
Let me explain. Imagine a library,
Okay.
but instead of using those old card catalogs,
Yeah.
you could just tell the librarian the book you want,
Mm-hmm.
and they instantly know exactly where to find it.
Okay.
That's kind of what a hash table does.
So it's like they have a superpower. They've memorized where every book in the library is.
Basically.
Yeah.
It uses this special function to turn a piece of data, like the title of a book, into a unique address where that information is stored.
Interesting.
And this makes finding data super fast, which is why hash tables are used in databases, password management, all sorts of things.
Okay, that's way cooler than I thought it was.
Right.
And less intimidating. I like it.
Exactly.
So we've done arrays, linked lists, stacks, queues, hash tables. What else is there?
Well, next up, things are about to get a little hierarchical because we're going to talk about trees.
Ooh.
Trees?
Mm-hmm.
Yeah, they're not just for the great outdoors anymore.
Not just for climbing and whatnot.
Exactly.
So we're talking about hierarchical structures with branches and nodes.
Right.
Definitely makes me think of family trees and things like that.
Yes, good analogy.
So how does that translate to the world of data? I don't quite get it.
Well, think about how a family tree shows all the relationships.
Okay.
Parents, grandparents, kids.
Yeah. Right.
It's the same idea with data. Branches are perfect for showing how information is connected in a hierarchy.
Oh.
Like when you look at your computer files.
Yeah.
Folders within folders within folders.
Right, it's like folder madness in there.
Exactly, that's a tree in action.
So trees are mostly used for keeping things organized then?
Yeah, organization is key.
Okay.
But that organization comes with some pretty cool benefits.
Like what?
Well, because of their structure, trees are great for searching and sorting data super efficiently.
Oh, okay, so it's like without these trees, it would just be a mess.
Imagine trying to find one specific file
Yeah.
buried deep in your computer.
Oh, it's already a nightmare.
Without those folders,
Yeah.
it'd be impossible. Like finding a needle in a haystack.
Right. That's a search I don't want to be on.
Exactly.
So we've got efficient searching. Anything else makes trees special?
There's a lot. Actually, there are tons of different types of trees.
Really?
Binary trees, B trees.
Okay.
Each one has its own strengths depending on what you're trying to do.
Ah.
It's why programmers love them. They're so versatile.
So it's like trees have specializations.
You could say that.
That's really interesting. I'm learning a lot.
Glad to hear it.
Okay, on to the next one. The article mentions something called graphs.
Okay, yeah.
Are these like the ones I struggled with in math class?
Maybe a little bit, but not quite as scary, I promise.
Good, because those gave me nightmares.
Don't worry about it.
Okay.
When we talk about graphs and data structures, we're talking about relationships.
Okay, so not plotting equations then.
Not exactly.
Gotcha.
Think about it like a social network.
Okay.
Each person is a point, a node,
Right?
and the lines connecting them show their friendships.
Okay.
It's a graph.
So it's less about numbers and more about connection.
Exactly.
All right, so where do these graphs come in handy in the real world?
Oh, everywhere. Social network analysis, obviously.
Right, of course.
But also things like mapping applications, figuring out the shortest route somewhere,
Okay, that makes sense.
or even understanding the connections in massive data sets.
So it's like graphs help us see the bigger picture.
Yeah. They reveal the hidden connections in all that data.
It's like those connect the dot puzzles.
Exactly. You start with a bunch of random points, and suddenly,
Picture emerges.
boom, there it is.
It's all starting to click now. I like it.
I knew you'd get it.
All right, last but not least, we've got heaps.
Ah, yes, heaps.
What's so special about those?
Imagine you're watching some kind of competition.
Okay, like the Olympics?
Sure, the Olympics.
Yeah.
The winner always ends up on top, right?
Right, on the podium.
That's what a heap does with data.
Okay.
It always keeps the biggest or the smallest element right at the top.
So it's like the VIP section of data.
Exactly. And that makes heaps super useful for things like priority queues.
Priority queues, what are those?
It's like in a hospital, some cases are more urgent than others.
Right.
A heap can help prioritize those urgent cases so they're addressed first.
I gotta say, learning about all these data structures, it's kind of like I'm discovering this whole secret language.
Right.
This whole secret language of how to make computers do their thing.
That's all about efficiency.
Yeah. And I always thought, like, algorithms were the cool kids on the block,
Yeah, they get all the glory.
but they're only as good as the data structures, right?
Exactly. It's like having a fancy sports car,
Okay.
but giving it square wheels.
It's not gonna work very well.
Not going to get very far with that.
So for those of us who aren't, coding all day, every day, why does this even matter?
Because this is what's happening behind the scenes of everything you do online.
Really?
Yeah.
Okay, like what?
Think about those recommendations you get on shopping websites.
No.
Or when your music app suggests a song you've never heard before,
Right.
but you end up loving it.
Yeah, how do they do that? It's kind of creepy.
That's the power of data structures at work.
Really?
Yep. Without them, searching the web would be like trying to find a needle in a haystack.
Oh, we talked about that earlier. It would be a nightmare.
Total nightmare. Everything would be so slow.